Hi kids, welcome to our home video for zoology class. Today we're going to do an experiment. I have an assistant here with me, Lou. He's going to help me out. We are going to be doing a lesson 12 experiment. You will find it on page 228 of your textbook. And I'm going to tell you what we need first. And then if you want to go get it and pause the video while you collect your supplies, you can do that. So today you are going to need page 207 in your notebook journal. Looks like this. Page 207, it's a scientific speculation sheet. You are going to need 2 cardboard cylinders, toilet paper rolls. We know that there is a shortage of these right now, so if you need to use something else that's kind of cylindrical, you could grab 2 water bottles, or maybe your mom has a cardboard tube laying around. You can measure that and cut it in half, and that will also give you 2 cardboard rolls. You will also need some wire, specifically 8 pieces. If you want to cut up a coat hanger with your parents' permission, you could do that. We had some copper wire sitting around and also some floral wire, which we've cut into 8 pieces that are the same length. So 8 pieces of wire. You will also need some pliers and some wire cutters. You also need a stopwatch, and it would be really great if you had an adult that could help you cut. Last but not least, safety first. You might want some eye protection. Safety goggles. If you don't have any sitting at home, you can wear a pair of swim goggles or a pair of glasses. Lou's are pretty cool. They've got this little side mesh on them so that in case the wire pops off and hits him in the eye, he's not going to get his eye hurt. All right, so if you want to pause and go get those things, you need your speculation sheet, 2 cardboard cylinders, 8 pieces of wire, pliers, wire cutters, a stopwatch, preferably an adult, and
a pencil.
Safety goggles. Oh yeah, you might want a pencil to write down some stuff. All right, go grab those, and when you come back, we will keep going. All right, now that you've got all your supplies collected, I'm going to tell you about our experiment today. The main purpose of our experiment is to give you some first-hand experience with the different stances of lizards and dinosaurs. So we know that a stance is the way you rest on your feet or your hands. We've talked about bipedal, which is what we are. We stand up on 2 feet. We've talked about quadrupedal, which is animals that stand on all 4, like a cat and a dog. And we've talked about reptiles that have a splayed stance. So they have longer limbs and shorter little feet. So their weight is spread out. We're going to see if stance makes a difference in how fast you move and also in how much weight you can hold. Is it better? Can you hold more weight if you're splayed? Or can you, don't give it away, or can you hold more weight if you're up high and have your weight closer, your limbs closer to your body? So, we're going to make a hypothesis. Louie, what is your hypothesis? You kind of gave it away already.
That standing straight up will go faster.
You think if you have limbs that are more under your body, you'll be better, go faster? Okay, so we're going to find out which is faster and which can hold more weight. Does stance make a difference in dinosaur and lizard movement? So on your scientific speculation sheet, put your name. You can put the date. You can write down your materials. And our procedure is going to be finding out what different stances make for reptiles and dinosaurs. Our hypothesis is going to be, Louis, what did you put? A reptile stance keeps him from being as fast as a dinosaur and from being able to carry as much weight. So write down, what do you think the outcome will be? Will a dinosaur be faster? Will a lizard be faster? Is stance going to make a difference in how much weight they can carry? All right, so let's make some stuff. Use the wire cutters and cut your 8 pieces. Ours have already been cut. It'd be good if they were about 6 inches long. Some of ours are a little bit shorter than that, but I think they're gonna work too. Bend half of your in half. So we measured ours, we marked them in the middle, and now we're going to bend them in half. So we have 3 inches here and 3 inches here. Louis, you want to do some of these? No. Okay. So bending these in half.
Why are you just going to do that?
I just lost my assistant. Okay. For the other half, the other 4 legs, we are going to measure, you could do 1 inch and 5 inches. I've done 2 inches and 4 inches. So one side is longer than the other. I'm going to bend those like this quickly. And then you're going to grab your cardboard tube. Right? There are 2, dinosaur and reptile. Louis, would you stick in the dinosaur legs? I have measured on my cone to make sure 1 inch from each end on both of these so that we are more accurate. We're not just guessing. I wanted to do that because if the distances were different, it would change the outcome of our experiment. All right, you're making the lizard, the reptile. I'm making the dinosaur.
Oh.
Did you want to make the dinosaur?
No.
Okay. Here we go.
Oh, this is really confusing. Can I use the one that already has been made?
No, just poke those in. Okay.
What would this stick? Maybe it's the gloves.
Don't poke yourself. All right, here is
That's why I'm wearing
my
the gloves.
dinosaur. Can you see him? And then I'm going to help Louis a little bit with his lizard. He's sticking his lizard's legs in. That's good. All right. So here is, so hopefully you can see the difference between our reptile. Oh, I might need an extra set of hands here. Can you help me stand him up? There. Whoa. He's a baby learning how to walk. Okay. Oh. That was our reptile. And this is our dinosaur. Okay? Now you at home can take your reptile and your dinosaur and smush them a little bit. So you can see which one seems to be able to carry more weight. All right, we're smushing our dinosaur. He's not really moving much. He seems to be able to hold his weight really well. Our reptile, on the other hand,
instead of his tail fell off.
We're even having a hard time standing him up.
His neck fell off.
Can you guys hear Barkley in the background? She's making a loud noise.
Can I show them?
Sure. We're going to have a canine pet visit. Here she comes. All right. My lizard is really having a hard time even standing up. So if I squish him, he squishes right down. Hopefully you're doing better. Maybe a piece of tape on the inside of your tubes for all of your animals would be helpful. All right, are you guys ready to see the most adorable dog ever? Here she comes. This is Barkley, our little canine friend.
Can you hold it? Why is it dog?
Okay, this is Barkley. She is a girl Chiweenie. She's half dachshund, half Chihuahua. And she is really sweet. You guys have heard me talk about her when we talked about canines in class. All right, will you go put her back, please? That was our pet moment. We'll have to show you some other pets in the future. All right, so we tried the dinosaur upright legs, and we tried the lizard splayed legs. And we found that our dinosaur was much better at standing upright and holding weight than the lizard with the splayed legs was. So stance does make a difference when you are talking about weight. You'll remember we talked about in the chapter this week, lizard-hipped and bird-hipped dinosaurs. So depending on where their legs came out of their body, they were able to hold or walk in different ways. You can look at page 216 for more information on those two kind. One was, do what? Your exercise? In a minute. Okay, 216 for more information on different hipped dinosaurs. All right, second part of our experiment. We're going to go to a hallway in our house, which is actually just our dining room. And I'm going to use my stopwatch to see if walking or, like a lizard, you want to run, or walking like a dinosaur is quicker. So first, let's see the bipedal run. Go. Just bipedal, up, up, up. That's quadrupedal. Which is bipedal? Go. Oh, that's fast. All right, I'll move out of the way. On your marks, get set, go. That was 4 seconds. All right, are we ready? Let's try the, you want to do the lizard? We're going to try the splayed leg run. One, okay, go. He looks funny, doesn't he? Okay, come to the door, I'm going to count. Ready? On your marks.
Wait, this one?
Splayed, yes. On your marks, get set, go. Seven seconds on that one. All right, he's worn out. Should we give you a little breather? Okay, so that was the bipedal, which is how people walk. Then we did the splayed leg, like the reptile. And when he's caught his breath, are you ready? You can walk to the door and then come back as the dinosaur. So he's walking to the door, and he's going to come back as a dinosaur.
Say what? I'm going to be a dinosaur.
Yes. Are you ready? Go. 5 seconds. So you can put that on your result sheet that the dinosaur was 5 seconds, the lizard was 7. And if you want to see how fast you can go just as a human, you can put that too under your results. So what is our conclusion? We use the cylinder with the wires, far from the body, and close to my assistant is very dramatic. Far from the body and close to the body, we found out the dinosaur can hold more weight and the lizard can hold more weight. We also found out that if your limbs are closer underneath your body, you are able to move more quickly than if you have splayed legs.
He died.
So now you can see why it was possible for dinosaurs to be so much heavier than lizards, and also why they might have been able to run more quickly than lizards. All right, well, that is the end of our experiment. I hope you've enjoyed this home video and my lovely assistant. We miss you guys and hope that you're doing well at home. Please reach out to us if you have any videos you want to send us of you doing experiments or anything else you'd like to share with us about what you're learning in science. We would love to hear about it. We will talk to you later. Bye, class.
Again.